Most languages let a function hand back exactly one thing. Go lets it hand back several. No wrapper object, no tuple you unpack, no out parameters, just two values. That sounds like a small convenience. It is not. It is the decision that gives Go its entire approach to failure, and it is why Go has no exceptions. The result types go in brackets. Open bracket, int, comma, int, close bracket. That says, calling this gives you back two whole numbers. The return statement lists both of them, separated by a comma, and the caller catches both with a single colon equals. We pass 9 and 4. 4 is smaller, so we get back 4 and 9, in that order. That is genuinely all there is to the mechanism. Two values out, two variables in. But notice what we did not need. No struct to wrap them in, no array to unpack, no passing in pointers for the function to fill. And here is the convention. You will see this in essentially every Go library ever written. A function that might fail returns its result, and an error together. Look at the failure path. We return 0 for the result, and a real error describing what went wrong. That 0 is not a meaningful answer. It is the 0 value, a placeholder, because we have to return something in that slot. And on the success path, we return the real answer and nil. Nil is Go's way of saying, there is nothing here. No error occurred. So the error slot is always filled in, either with a problem or with nil to say there was none. 3 rules. You will type this shape 1,000 times, so it is worth having it explicitly. On failure, return the 0 value for the result, plus a real error. On success, return the actual result, plus nil. And the caller checks whether the error is nil immediately, on the very next line, before touching the result at all. That third one is the discipline that makes the whole thing work. The result is only meaningful once you have checked the error. And this is the caller's half of it. Catch both values. Then immediately on the next line, ask the question, is the error nil? If it is not nil, something went wrong, and we deal with it there. 10 divided by 4 worked fine. So error is nil, and we print 2.5. You will see this written slightly more tightly in real code. Usually the error case returns early, as a guard clause, and the success path continues unindented below. Exactly the shape from the last video. This is the part worth pausing on, because it is a real departure from most languages. Go has no exceptions for ordinary failures. Nothing is thrown. Nothing sails past your code to be caught somewhere far away. Errors are ordinary values. They come back from the function, and you deal with them on the next line, or you deliberately pass them upward. The trade is honest. Go code has more error checking visible in it than a language with exceptions, and people do complain about that. What you get in return is that every place a thing can fail is written down, in the open, where you can see it while reading. Module 7 goes properly into what an error actually is. For now, just get comfortable with the two-value handshake. Sometimes you genuinely do not want one of the values, and the blank identifier throws it away. Here we parse the text 42 and keep the number, discarding the error. And here we do the opposite. We parse something that is not a number at all, throw away the useless result, and keep the error so we can look at it. Notice that a toy is itself a value, error function. The standard library follows exactly the same convention your own code does. There is no special mechanism for built-in functions. One warning about that underscore, though. Using it to discard an error is a genuine code smell in real projects. It is precisely how bugs hide, because the failure happens and nobody ever hears about it. Throwing an error away should be a decision you have thought about, not a way to make the compiler stop complaining. You can also give the results names in the signature. Those names become ordinary variables inside the function, already set to their 0 values, so we assign to them with a plain equals rather than declaring them. 195 minutes is 3 hours and 15 minutes. But the real reason to name results is not the variables. It is documentation. Look at the signature on its own. Split, taking a total, returning hours and minutes. You know instantly which number is which. Compare that with a signature that just says open bracket int, comma, int. Same function, and now you have to go and read the body to find out what order they come in. Go does also allow a bare return with named results, which returns whatever those variables currently hold. It is legal, and it has one genuinely good use with deferred functions that you will meet in the errors module. But in ordinary code, spell out what you are returning. A bare return at the bottom of a long function is a puzzle for the reader. Nothing in the language stops you returning more than 2 things. You can return 6 if you like. But past about 3, callers start losing track of the order, and a caller that swaps 2 of them gets a bug the compiler cannot catch because they are all the same type. So when you find yourself reaching for a 4th return value, that is the signal to return a struct instead and give every field a name. That is what the structs module is for, and it is 2 modules away. 4 things to keep. Multiple result types go in brackets, and the return statement lists them in the same order. On failure, 0 value plus a real error. On success, the real value plus nil. The caller checks the error immediately, before touching the result. And name your results when the types on their own would leave somebody guessing which is which. That handshake is the backbone of every Go program you will ever read. Your turn. Write a function called apply tax. It takes a price and returns 2 things, the tax, which is 10%, and then the total price, in that order. Print both to 2 decimals. Pause and try it. Here's the answer. 2 float 64s out, so the result types are float 64, float 64 in brackets. 10% of 50 is 5, and 50 plus 5 is 55. Now, this function has 2 results of the same type, and nothing in the signature says which is which. This is exactly the case where naming them would help. Writing it as returning tax and total, both float 64s, would tell the caller the order without them having to read the body. Worth doing. That is multiple return values, and the value, error pattern built on top of them. Next up, functions that accept any number of arguments. You have been calling one since the very first video without noticing.